welcome you back. Now, we are going through the Laplace transform of various functions. At a glance, let us see the some functions and corresponding Laplace transform which you should remember, like Laplace transform of 1 is 1 by s where s greater than 0. Laplace transform of t power n where n is positive integer is factorial n by s to the power n plus 1. Laplace transform of e power a t, this equals 1 by s minus a. Laplace transform of sin a t equals a by s square plus a square. Laplace transform of cos a t is 1 by s square plus a square. Laplace transform of sin hyperbolic a t, as I have shown, a by s square minus a square where s is greater than modulus of a, and the Laplace transform of cos hyperbolic a t is equals to s by s square minus a square where s is greater than absolute value of a. Now, let us see some examples how to find out the Laplace transform of some complex functions using this basic Laplace transform of these functions. The first example is, say, I want to find out the Laplace transform of sin t cos t. So, your Laplace transform of sin t cos t, obviously in terms of trigonometric functions, I can write down Laplace transform of half into sin 2t, which is again I can write down half into Laplace transform of sin 2t. Now, we know the Laplace transform of sin a t is a by s square plus a square. Therefore, directly I can write down here a is your 2. So, 2 by s square plus 4 where s is greater than 0. Please note that for the function a is equals to 2. So, that you will obtain the Laplace transform of sin t cos t, which is 1 by s square plus 4 for s greater than 0. So, Laplace transform of sin t cos t is 1 by s square plus 4, and so just quickly let me see this one, and value is 1 by s square plus 4. The next example, let us take f t, a function where f t equals 0 when 0 lies between when t lies between 0 to 1, it is equals 2 when t lies between 1 to 2, and for t greater than 2 it is 0. So, the function is Laplace transform of f t, which you are writing as 0 to infinity e power minus s t into f t dt. So, if you see now this 0 to infinity, the function is defined in 3 intervals 0 to 1, 1 to 2 and greater than 2. So, I have to break this integration into 3 parts, 0 to 1 e power minus s t into value of f t in 0 to 1 is 0. So, it is into 0 dt plus 1 to 2 e power minus s t into, in 1 to 2 the value of the function f t from the given, it is t dt t plus 2 to infinity e power minus s t into value of the function is 0. So, 0 dt. So, this is nothing but 1 to 2 e power minus s t into t dt, and if I evaluate the integral, then it becomes minus t by s. I am not going to the integration here, 1 by s square e power minus s t, and if you find out this limit value will be from 1 to 2. So, if I put the limits, you will obtain 1 by s plus 1 by s square into e power minus s minus 2 by s plus 1 by s square into e power minus 2s. One is for minus 1s for lower limit, another one is for the upper limit. So, it is minus 2s. So, whenever you have a function which is defined in many intervals, you will simply 0 to infinity, you will break it in those many intervals like we did it here, 0 to 1, 1 to 2 and 2 to infinity, and I can solve the problem like this way. And so, just I was telling you, simply I can get it like this, and if I evaluate, I am obtaining this. Our next example is, we want to find out Laplace transform of sin root t. Please see that we have done already the Laplace transform of sin t, we know it, but sin root t we do not know it. So, what we will do? Laplace transform of sin root t, in various ways I can do it. Laplace transform of sin root t. One thing I can do it, simply I can write down Laplace transform of this sin root t, I can simply expand it in Taylor series, and in Taylor series if I expand it, I will obtain root t minus root t whole cube by factorial 3 plus root t whole to the power 5 by factorial 5, and like this way I can continue factorial 5 and like this. This is your factorial 5, and like this way I can continue over here. This is this. So, now this is basically nothing but Laplace transform of t to the power half minus the next one is t to the power 3 by 2 by factorial 3 plus t to the power 5 by 2 by factorial 5, like this way we can proceed. And we know now the Laplace transform of each of them, because this I can write it now, Laplace transform of t to the power half minus Laplace transform of t to the power 3 by 2 by factorial 3 plus Laplace transform of t to the power 5 by 2 by factorial 5 using the linearity property. Laplace transform of a f1 ft plus a f1 t plus b f2 t, I can write down a into Laplace transform of f1 t plus b into Laplace transform of f2 t. So, I can write it as an individual Laplace transforms, and this is equals t to the power half, I can write down gamma 3 by 2 by s to the power 3 by 2 minus 1 by factorial 3 will come. Here it will be gamma 5 by 2 divided by s to the power 5 by 2 plus 1 by factorial 5 into gamma, it will become then 7 by 2 s to the power 7 by 2. Please note one thing, that Laplace transform of t to the power n is nothing but gamma n plus 1 by gamma n plus 1 by s to the power n plus 1. So, if I use this formula, Laplace transform of t to the power n equals gamma n plus 1 by s to the power n plus 1, I will obtain this thing, and this I can write it simply root over pi by 2 to the power, because gamma half is pi. So, using that formula always I can break it, 2 to the s to the power 3 by 2 will be in common, 1 minus 4 by s plus 1 by factorial 2 1 by 4 s whole square minus 1 by factorial 3 will come into 1 by 4 s whole cube, and like this way it will continue. And this if I break it, then it will be root pi divided by 2 to the 2 into s to the power 3 by 2, and this is nothing but a series, that is e power minus 1 by 4 s. So, this is again a series. Therefore, Laplace transform of sin root t is root pi by 2 to the power s into 3 by 2 and into e power minus 1 by 4 s. This we will see afterwards how we are doing it using some other properties also. So, this I have written here, whatever I derived, that only I am just showing now, and so these steps are coming, and the last step is the value is e power minus 1 by 4s. So, if you see, if the function is complex, it becomes difficult sometimes to find out the Laplace transform, because in each case I have to find out the Laplace transform or I have to evaluate the integrals. To make it life simple, that is, we will develop certain, we will study certain properties of Laplace transform with which very easily we can find out the solution of Laplace transform. The first property is this one: if Laplace transform of f t equals f s, then Laplace transform of e power a t into f t is f of s minus a. Please note this one, that if Laplace transform of f t is f s, then Laplace transform of e power a t f t equals f by s minus a. Let us see how we can derive this one. So, your f s, we know it, this is nothing but Laplace transform of f t. From the definition of Laplace transform, we can write down this as an integral e power minus s t into f t dt. Now, start with f of s minus a. What will be f of s minus a? From here, if s is replaced by s minus a. So, from here I can write down 0 to infinity, this s I am now replacing by s minus a. So, that e power minus s minus a into t into f t dt. This remains as it is over here. Now, this I can break it into two parts, that is e power a t and e power minus s t, and e power a t I can bring outside the integral. So, sorry, I cannot bring it outside the integral, I am sorry, because t is there. So, I can write it 0 to infinity e power minus s t into e power a t f t dt. And now, your function is what? Now, you see, this is your f t, new f t, say. So, this what I can write down? This is nothing but Laplace transform of e power a t into f t, because Laplace transform of e power a t into f t, by definition it is 0 to infinity e power s t into this function, that is e power a t into f t dt. So, therefore, your this completes the proof that if Laplace transform of f t is f a, then Laplace transform of e power a t f t is f of s minus a. So, let us see now again just the same thing we are showing by this one, and this completes the proof. The second translation or shifting theorem is, if Laplace transform of f t equals f s, and if I consider a new function g t such that g t equals f of t minus a, capital F of t minus a, when t greater than a and is 0 for t less than a, then Laplace transform of this function g t is e power minus a s into f s. Or in other sense, if I have to prove this one, in that case I will tell that if your Laplace transform of basically f of t minus a is equals to e power minus a s into f s, this I have to prove when I know that Laplace transform of f t, this is equals, this will be capital F, Laplace transform of f t is equals to f s, it is known to us. Now, from the definition, let us start with Laplace transform of g t. Laplace transform of g t is 0 to infinity e power minus s t into g t dt. This I have to break it into two parts, 0 to a and a to infinity, because your function is t greater than a and t less than a. In 0 to a, the function is 0, so this part will be equals to 0, and this part will be e power minus s t into f of t minus a dt, a to infinity, this one. Now, on this, if I put t minus a, this is equals x. On this, I am putting t minus a equals x. Then your a t minus a x means it will be 0. So, integration will be from 0 to infinity, because at t equals a, x is 0, and at t equals infinity, x will be infinity. 0 to infinity e power minus s into a plus x f x dx. This e power minus a s, I can bring it outside. So, this equals, I can write down e power minus a s 0 to infinity into e power minus s x into f x dx. This e power minus s x into f x dx, if I wish, I can change the parameter x to t, or in other sense, this integral I can write it as like this: e power minus a s 0 to infinity e power minus s t into f t dt. Once I am writing this, by changing the parameter x to t, I can always do it. So, e power minus a s 0 to infinity e power minus s t into f t dt, and this is nothing but the Laplace transform of f t, or in other sense e power minus a s into Laplace transform of f t, and this I can write down e power minus a s into f s. So, therefore, we have shown that the Laplace transform of g t, this function where g t has been defined earlier, is equals to e power minus a s into f s. This completes the proof of this one. Now, same thing we are just showing here, so that you can better see it in the proper way. So, we are putting t equals x, t minus a equals x on this. We are getting this integral 0 to infinity, and then Laplace transform of g t is equals to e power minus a s into f s. This completes the proof of this. Next is change of scale property. If Laplace transform of f t equals f s, then Laplace transform of a t, that is, you see the parameter t is changed to a t, one parameter has been multiplied. The effect is it will be the equals to 1 by a f of s by a. So, if Laplace transform of f t is f s, then Laplace transform of f of a t is equals to 1 by a f of s by a. For proof of this one, we will start with Laplace transform of f of a t. This is equals 0 to infinity e power minus s t f of a t. From the definition, I can always do it. Put here now a t equals x. Whenever I am putting a t equals x, then 1 by a, the limit will remain same, 0 to infinity e power minus s into x by a will be here, t is x by a into f of x dx. So, this is equals, you can write down 1 by a 0 to infinity e power, just change the property, that is minus s by a into t, e power will come into f of t dt. That is, you are changing the parameter x by t again without changing any other properties. So, this I can write down e power minus s by a t into f t dt. So, this is equals 1 by a, from the definition, Laplace transform of A t is e power, you know the Laplace transform of f t. This we write down as f s, which is equals to 0 to infinity e power minus s t into f t dt. So, if I replace s by change s to s by s a, then you will get e power minus s by a into t into f t dt, and this will become in place of f s, this will become f of s by a. So, 1 by a into f of s by a. So, therefore, Laplace transform of f of a t, this is equals 1 by a f of s by a. This completes the proof. So, just quickly just see this thing. This is equals 1 by a f of s by a. So, the question comes, why I am going through these properties? What is the use of these properties? As I told you earlier, these properties will help you to find out the Laplace transform of various complex functions. Let us see how we can use these properties. Not only these properties, like this, so many other properties are there, which we will discuss slowly. First, let us take the example. We want to find out the Laplace transform of t q into e power minus 3 t. So, we know the Laplace transform of t cube, we know it, t power n, that is factorial 3 by s to the power 4, this we know it, or in other sense this is equals 6 by s to the power 4, factorial 3 is 6. Also, you have this theorem, we know that Laplace transform of e power a t f t, this is equals f of s minus a. So, Laplace transform of e power minus 3 t into t cube, this is equals, already you know Laplace transform of t q is 6 by s to the power 4, and e power a t, Laplace transform of e power a t f t is f of s minus a. Therefore, Laplace transform of using this property e power minus 3 t into t cube, a will be a is equals to minus 3. So, it will be 6 by s plus 3 whole to the power 4, because a is minus 3 over here. So, f of s minus a. So, 6 by s plus 3 whole to the power minus 4. You see the advantage. Here your problem was to find out the Laplace transform of this. If I have to use the direct method, that is Laplace transform of this equals 0 to infinity e power minus s t into this integral. So, I have to evaluate one complex integral, but with a very simple calculation using this property, we are finding the Laplace transform of a complex function. This is the use of the properties which we will do. Let us see some more examples. So, just from the first shifting theorem directly you are writing this one. Let us see another complex problem. Laplace transform of e power minus 2 t into 3 cos 6t minus 5 sin 6t. So, we will start from here. Let us see this thing. Laplace transform of 3 cos, it will be 6t, 3 cos 6t minus 5 sin 6t. I know that Laplace transform of cos a t s by a square plus a square, Laplace transform of sin a t, I know it a by a square plus a square. So, I can find out the Laplace transform of this function very easily. So, this will be 3 into s by a square plus 6 square minus 5 into a means here it is 6. So, it is 6. So, s square plus 6 square, and if I make the calculation, I will obtain 3s minus 30 by s square plus 36, and this I am assuming as f s. Therefore, from here Laplace transform of e power minus 2t into 3 cos 60 minus sin 60. Again I will use the earlier property, and this is nothing but equals to f of s plus 2. So, you know what is f s. So, f of s plus 2 is nothing but 3 into s plus 2 minus 30 by s plus 2 whole square plus 36. This is equals 3s minus 24 if you evaluate it, minus divided by s square plus 4s plus 40. You see the simplest calculation. Using simple property by simple way, I am finding the Laplace transform of various functions. And this is the case here. Simply we are going through this, and once we are going through this one, then we are obtaining the solution as this one. Let us see. So, the ultimate result is 3s minus 24 by s square plus 4s plus 40. Next, see another problem, e power t into sin square t, means combination of e and the function sin t also. Since I know Laplace transform of e power a t f t, if I know Laplace transform of f t, from there I can talk about Laplace transform of e power a t f t dt. Therefore, for this problem, say this is your problem, Laplace transform of e power t sin square t. So, first I will try to find out the Laplace transform of sin square t over here. Please note this. Then only I will try to apply this. So, once I am doing this thing, Laplace transform of sin square t, this using trigonometry I can break it as half into 1 minus cos 2t. So, that I know the Laplace transform of 1, I know the Laplace transform of cos a t, I can find out easily. So, half into 1 by s, Laplace transform of 1 is 1 by s, minus this is s by s square plus s square, that is 2 square, s square plus 4, and this is equals 2 by s into s square plus 4 we are getting, and this is your again f s. Once I am getting f s, therefore, Laplace transform of e power t into sin square t, this is equals to, is nothing but f of s minus 1 here, t is this, e power t into sin square t will be then f of s minus 1. F of s minus 1 means this will be 2 by s minus 1 into s minus 1 whole square plus 4, and you can make it simpler also by this way. So, I think it is clear. In the next classes, we will do some more examples and we will go through some more properties on Laplace transforms.